Okay, Year 11, I'm going to go over some of the questions and some of the work from our first jump into Year 12, and I'm going to do geometrical applications of calculus and exercise 2.1. But first we have to have a look at some notes. Now, it's important that when we find or when we differentiate something, what are we finding? We're finding the gradient of the tangent to the curve at any point. So we can call it the gradient function. Now, but remember, it's the gradient of the tangent. So if we have a function, and I'll just draw a cubic. We have a standard cubic. And we drew little tangents on here. Oh God, that's a terrible tangent. I drew one here. Oh, now I've rubbed that out. I'll just undo that. Okay. So if I drew a tangent, there's one, and these ones are getting, you can see them, and I could draw one there, and one there, and one there, and one there, and they're getting there, and there, and there. But I don't want to draw the tangents. I want to know the sign of the tangent. Now remember, that's a positive gradient. That's a negative gradient. And that's a zero gradient. So I can just use the sign. Well, that's positive, that's positive, that's positive, that's positive, that's positive. Ooh, that's zero. And now they're getting negative, negative, negative. All changes down here, and there's another zero. And positive, 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 positive. So when you see these symbols that are on the left here, that's telling you the sign of the gradient of the tangent, whether it's a positive tangent or line, or whether it's a negative or a zero. Now, let's have a think about, well, let's take the cubic again. Now, we tend to think of the curves or anything on the Cartesian plane from left to right. And we want to know whether or not this curve is increasing or decreasing. Well, if I'm going along here, if I'm going along this bit, oh, it's going up, it's going up, it's going up, it's going up. Oh, it stops. Now it's coming down, it's coming down, it's coming down. Oh, it stops, and then it's going up, and then it's going up, and then it's going up. But for me to do that, I've got to draw it. Now, if I just look at the sign, positive, 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 zero, negative, 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 zero, positive, 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 positive. And what do we see? Well, when the curve is going up, the gradient of the tangent is positive. And when the curve is going down or decreasing, the gradient of the tangent is negative. And when the gradient of the tangent is zero, the curve is stationary. So in your notes, you need to have this. If f dash x, that's the gradient, is positive, that means greater than zero, the curve is increasing. If f dash x is less than zero, well, and that means it's negative, it means it's decreasing. If f dash x equals zero, then the curve at that point is stationary. It's neither increasing nor decreasing. Now, another term here is monotonic. And monotonic means it's always, it's the same. It doesn't change. It doesn't change. It's always. So if a curve is monotonic increasing or monotonic decreasing, that means it's always going up. Oh, I wonder what sort of curves do that. Well, here we go. Let's take y equals 2 to the x. This is what it looks like. And what's the gradient doing of the tangent? Oh, the gradient of the tangent is positive, 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 positive. That's a monotonic increasing. Oh, what's a monotonic decreasing? Well, let's take y equals negative root x. And that's that one. And what's the gradient of the tangent? Negative, 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 negative. That is monotonic decreasing. So now we know our notes, and you need to make sure you've got some sort of notes there. Write that in your notes, that bit. Make sure you know what monotonic increasing, monotonic decreasing is. Let's now have a look at some of the questions. All right, so here we go. Now, I'm going to do the first two. Oh no, I've already done a cubic. I'll let you do that. I might do, I'll do A and D, and then you can have a go at the other ones. The answer's in the back. So what happens here? Oh, positive, 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 0, negative, 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 negative. Oh, look at this one. Positive, 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 0, negative, 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 0, positive, 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 come on, scroll down. 0, negative, negative, negative. Okay, so it's this one. This one is increasing, then decrease, or 0, decreasing, 0, increasing, 0, decreasing. Okay. Now, question 2. For what values of x is that curve decreasing? Well, I could draw it, and I'm pretty quick at drawing this because it's a parabola. Factorise out the 2x. Sorry, factorise out the x, and I get 2x. So I get y equals x outside of 2x minus 1. And I go, all right, well, take the x out. That means x equals 0, x equals a half. There it is. It looks like that. I think I did this incorrectly today. I think if you check the work on the board, you'll see that I did do it incorrectly. I'm just looking on the board work now. Yeah, no, that's year 10. And that's here we go. No, did it right. Now, I know that's a half, and I know that's 0. Now, okay, I've got to find out find the values of x for which it's decreasing. Okay, it's going down, down, hit 0 there, plus, 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 plus. How do I know where that point is? Well, I know it's symmetrical between 0 and a half, so I know that that point will be a quarter. I also know that it's minus b on 2a, so I could have taken minus 1 on 2 times 2, which is a quarter. And then I can sub that in, and when we did that today and I substituted it in, oh, I didn't get it. I don't need it. I don't need it anyway. Well, I'll just quickly do it. It's 2 times a half squared. Half squared is a quarter, so 2 1/4 is a half minus a quarter. Oh, well, it should be negative. Half squared. Oh, I've been putting in 2 times a quarter, it's a 6. Yeah. So 2 times a quarter squared minus a quarter. This is what y equals. That's going to be 1 on 16, 2 on 16, 1/8 minus a quarter. So that's 1/8 minus 2/8, which is negative 1/8. So it's negative 1/8. But I don't need it because it said for what values of x is it decreasing? Well, it's decreasing. It's decreasing to the left of that x value, to the left of this point. So it's decreasing when x is less than, not equal to, because at x equal a quarter, it's 0, it's stationary, less than a quarter. Wow, that's a lot of work. Yes, it's too much work for what you need to do. What I said is you could do it that way. But we're lucky because we wrote these notes up here. It's coming back. And we know that a curve is decreasing when the derivative, the gradient function, the gradient of the tangent, is less than 0. Okay. So let's do this a different way. Question 2. Y equals 2x squared minus x. Y dash is 4x minus 1. When is y dash less than 0? Well, when 4x minus 1 is less than 0, when 4x is less than 1, when x is less than a quarter. Much easier now that we know what we're doing. Righto. You're going to do all these, so I'm now going to do a couple of others and see how you go. So I'll do 3 really quickly. You should have a go at yourself if you want to. F of x, I've got to show where it's increasing. So f of x is 4 minus x squared. F dash x is minus 2x. When is it increasing? When is minus 2x greater than 0? All right, that's when it's going to be decreasing. Well, when x divided by negative 2, change the sign, x is less than 2. 0, peanut, divided by 2. And x is less than 0. That was a bit of a tricky one. I better check that because I want to make sure that I'm correct. Could really draw it. I know it's a negative parabola moved up one, so it looks like this. Yep, and it's increasing, it's going up from 0 on. Let's jump to 5. Show that f of x equals minus 2x minus 7 is monotonic decreasing. All right, well, f of x equals minus 2x minus 7. Well, f dash x equals minus 2. Well, the gradient's always minus 2. Therefore, f dash x is always less than 0. Hence, monotonic decreasing. Now let's have a look at some of these other ones. So let's have a look at question 8. Find all the values for which this curve is stationary. And it's a cubic. So I go y equals 2x cubed plus 3x squared minus 36x plus 9. Oh, y dash equals 6x squared plus 6, hold on, 6x squared plus 6x minus 36. Well, when it's stationary, the curve is stationary when y dash equals 0. Okay, 0 equals 6x squared plus 6x minus 36. We'll divide everything by 6. 0 equals x squared plus x minus 6. Oh, I wonder what I can factorise that. Two things multiply out to 6 and add up to 1. I bet that's x plus 3, x minus 2, which means it'll be stationary when x equals -3 and x equals 2. Now I'm just going to open up to the answers here so that I can check as I'm going along. And I've got the wrong textbook. I've got the green one. So if I grab the purple one and I'm doing 2.1 exercise question 8. Yeah, x equals -3, x equals 2. Okay, let's jump a few. So what are they going to be asking you? They're just going to ask you to find the station points, find where it's increasing, find where it's decreasing. So we'll go along here and we'll have a look at question 15. And question 15 says, evaluate A and B if it has a stationary point. If it has a stationary point at x equals -1 and 2. So what am I going to do? So here we go with question 15. So y equals x cubed minus 3 ax squared plus bx minus 3. Okay, so we'll differentiate it. Y dash equals 3x squared minus 2ax plus b. Now it says it has a stationary point at x equals -1, x equals 2. Well, that means y dash equals 0 when x equals, what were they again? -1 and 2. -1 and when x equals 2. So we'll put those in and see what we get. So 0, let's put the -1 in first. 3 times -1 squared minus 2a times -1 plus b. And what do we get? 0 equals 3 minus 2a plus b. Oh, here we go. 0 equals 3 plus 2a plus b. Now, let's do the other one. 0 equals 3 times 2 squared minus 2a times 2 plus b. What do we get? 3 times 2 squared is 4, is 12 minus 4a plus b. So now I've got two equations. I'll call that equation number 1. I'll call this equation number 2. And if I subtract those equations, so if I go equation number 1 minus equation number 2, what will I get? 0 minus 0 is 0. 3 minus 12 is -9. 2a minus 4a, that's 6a. And b minus b, that goes. It eliminates. That's what's called elimination. So I get 9 equals 6a. So I get 9 on 6 equals a, which gives me 1.5 equals a. I'm just going to check that. It's question 15. A is 1.5. And all I do now is sub that in to either of those equations. So sub a equals 1.5, into 1. So I get 0 equals 3 plus 2 times 1.5 plus b. 0 equals 3. 2 times 1.5 is 3. 0 equals 6 plus 3. 6 plus b minus 6 equals b. And that's done. And then you check it in equation number 2, but I'm going to move on. Well, let's have a look at some of these other ones, some of the 20s. I'm not that fussed about 17 to 20. I want to go to 23. Find the stationary points on the curve. And some of these are getting a bit hard. So 23, 24, 25, 26, and 27. So I'm going to do 23. Now, 23, they're going to start dealing with things that require you to use product rules and indice laws to get the derivative out. So I'm going to do 23. Y equals 3x minus 1 and x minus 2 to the power of 4. So question 23. Y equals 3x minus 1. What was it? And x minus 2 to the 4. X minus 2 to the 4. And we've got to find the stationary points, the points where the curve is stationary. Well, it's a product rule. So y dash is the first, 3x minus 1, times the derivative of the second, or 4 outside of x minus 2, all cubed, times the derivative of what's inside 1, plus the second, x minus 2 to the 4, times the derivative of the first. Well, the derivative of the first is just 3. Now, when you do this, factorise before you simplify. I'm going to take x minus 2 cubed out of both sides. So I'm going to get y dash equals x minus 2 cubed. Now, if I take it out of the first bit, I'm left with 4 3x minus 1. If I take it over here, I've got 3 and I've got x minus 2. I've only got one of them. Okay, so y dash equals x minus 2 cubed. And in here, I get 12x minus 4 plus 3x minus 6. Okay, x minus 2 cubed, leave that alone. And here, 12x plus 15x, minus 4 minus 6 minus 10. Now, when will that equal 0? When does y dash equal 0? Well, it equals 0 because I've got this multiplication here when either of these things equals 0. So that'll equal 0 when x equals 2, and this will equal 0 when 15x minus 10 equals 0, which is 15x equals 10, which is x equals 10 on 15, or the third. That was question 23, so I'm just going to check it because I don't want to be giving you the wrong answers. They got 2 and 0, 2/3. Oh, of course, idiot. It's not 1/3, it's 2/3. Now, you need to find the y values also. Now, I'm not going to do that for you. You can do that. Sub it back into y equals. I'll start it here. So you put y in, and you go back to what you had. If I go y back in here, well, that one's pretty easy. 3x minus, so I've got 3 times 2 minus 1 times x minus, 2 minus 2 to the 4. Well, that's going to be 0. So I don't even have to use my cat. That's going to be 0. So this stationary point is 2, 0. Here, when I do 2/3, when I put it in, I'm going to get y equals 3 times 2/3 minus 1 times 2/3 minus 2 to the 4. Now, I'm not going to do that on my calculator. I'm just going to look to the answers, and I'm hoping you're going to do it on your calculator. They get 3 and 13 on 81. I'm going to do one more, and I'm going to leave it to you then. So let's have a look. I'm going to do 24. I want you to have a go at it first. X root x plus 1. Find the stationary point and exact value. So 24, because I reckon you're going to have a bit of trouble there. So 24, y equals x root x plus 1. Well, we have to write things in index notation to differentiate them. X plus 1 to the half. And again, I'm going to need the product rule. So the derivatives, y dash is the first, x times the derivative of the second, which is a half, x plus 1 to the minus a half times the derivative of what's inside 1, plus the second, x plus 1 to the half times 1. Okay, so I get x on 2 times, now negative a half is 1 over root x plus 1. Plus here I've got root x plus 1. Okay, I think I'm going to need a common denominator here. So x on 2 root x plus 1. And here we've got root x plus 1. I need to get a common denominator. I know what I'll do. I'll times this by 2 root x plus 1 on 2 root x plus 1. And that'll give me a common denominator over here. So I get x on 2 root x plus 1. And here I'll get, root x plus 1 times root x plus 1 is x plus 1. Remember, I've still got to multiply by 2. And here I get 2 root x plus 1. Okay, here I get x plus 2x plus 2. And on the bottom, I get 2 root x plus 1. Now, there are some important things you've got to know here. And by the way, this is a gradient. This whole thing can only equal 0 when the numerator equals 0. It can only, so I'm going to do the top in a minute. I'm going to simplify it as well. But you need to look at the bottom first. X cannot equal negative 1, because then I'll divide by 0. And x must be greater than, x plus 1 can never be less than 0. So x has actually got to be, has got to be greater than. That's got to be greater than 0. So x has got to be greater than negative 1. It can't equal negative 1. It's got to be x must be greater than negative 1. So if we get that as one of our solutions when we do this next bit, we can't be right. So here we go. What have I got? Y dash equals 3x plus 2 on 2 root x plus 1. Now that's a y dash will equal 0 when the denominator equals 0, 3x plus 2 equals 0, 3x equals negative 2, x equals negative 2/3. Now, is negative 2/3 greater than negative 1? I think it is. And I'm just checking the answers. Negative 2/3. But they also want the y value. So I have to go back. The y value. what was the original equation? X root x plus 1. Okay, so y is going to equal negative 2/3 square root negative 2/3 plus 1. Well, that's negative 2/3 times root 1/3. Well, negative 2/3 times 1 on root 3. Oh, that's a bit ugly. Why don't we rationalise that? So I'm going to just times that by root 3 on root 3. Doesn't change anything. So now what have I got? Negative 2 times 1 times root 3. And on the bottom, I've got 3 times root 3 times root 3. That's 3 times 3, which is negative, I'm going to put that out the front, 2 root 3 on 9. So the stationary point is negative 2/3 and negative 2 root 3 on 9. Let's just check and see how that looks. 24, and they're right. And that was pretty difficult. So what are you going to be doing with these? You're going to make sure you recognise that if the derivative is greater than 0, the curve is increasing. If the derivative or the gradient function is less than 0, the curve is decreasing. If the derivative equals 0, the curve is stationary. Monotonic, it's always doing whatever it's doing. It's always increasing, it's always decreasing. To find when it's increasing or decreasing, just differentiate it, make it less than 0, greater than 0. To find the stationary points, you've got to put it equal to 0. There's a lot of work there that you need to make sure you get done before our next lesson. Good luck.